In this lecture, we are going to discuss some more example on analytic function. If fz equal to my u plus iv and u minus b is equal to e to the power x cos of y minus sin y, then find fz in terms of z. Answer: we have given u minus b is equal to e to the power x cos of y minus sin y, and fz equal to u plus iv. Therefore, ifz will be, if I multiply this equation by I, then it will be I u, and this will be I square b. So this is I u, I square is minus b. Therefore, if I add these two equations, then in the left hand side it is 1 plus I fz, and it is equal to 8 real part of this equation. With real part of this equation, this is u minus b, and this is, take I common here, it is I v plus u. The next step, it will be here. This implies 1 plus I f of z. Now I am writing capital U plus I capital V. See, do one thing. You should write this capital FZ. Where capital FZ is my 1 plus I fz, and capital U is my u minus b. Here it is u minus b. Here it is u minus b. It is ex cos y minus sin y. So write this ex cos y minus sin y. Then b u plus b, and here it is not given. You are asked to find fz in terms of z. Therefore, phi 1 z0 phi 1 xy, not z0, phi 1 xy, not therefore. Consider this. Let phi 1 xy will be del u, del capital U, okay, not small u, del capital U by del x. Let phi 1 xy will be del capital U by del x, that is partial differentiation of this with respect to x treating yx constant, that is partially differentiate this, I will get the function x, then cos y minus sin y, bracket close. Now phi 1, therefore put x equal to z to apply Milne-Thomson method. This is e to the power z, this is cos of 0 minus sin 0, and this will be here I1 z0 is my e to the power z. Since this cos 0 is 1, sin 0 is my 0, so it will be e to the power z, and this is phi 1. Next again, phi 2 z0 and phi 2 z0 will be my del capital U by del y, that is partially differentiate u, capital U equal to ex cos y minus sin y, partially differentiate this treating x as constant, partially differentiate u with respect to y treating x as constant. This will be ex. Here differentiation of cos y will be minus sin y, and differentiation of sin will be cos y. Okay. Therefore, phi 2, this will be xy, not z0. Initially it is xy, not z0. You can check it out in the Milne-Thomson method. Initially it is xy. U is a function of xy. Now then put x equal to z, y equal to 0. You will get e to the power z minus sin 0 minus cos 0. And this is equal to minus e to the power z. As this is equal to 0, this is 1. So this will be minus e to the power z. Now by Milne-Thomson method, we have Thomson method, we have f of z is equal to integral phi 1 z0 dz minus integral phi 2 z0 dz plus c, where c is constant of integration. Now from here fz is this function 1 plus I fz, and phi 1 z0 will be this function, phi 1 z0 will be this, and this is phi 2 z0 will be this one. So write this. This implies 1 plus I fz, not fz, is equal to integral e to the power z dz minus integral here u is given, so here it is minus, then this is minus e to the power z dz plus c. Here this is minus ez, this is plus ez, so putting these values here, in here, we will get this one. So this is equal to e to the power integral e to the power z dz, take minus outside, this is plus I, integral e to the power z dz plus c. Take integral e to the power ez dz common, it will be 1 plus I, integral ez dz plus c. So this is equal to 1 plus I fz. Dividing this equation by 1 plus I, we will get fz e to the power z dz plus c by 1 plus I. Now integral of this will ez, this will be integral of fz equal to e to the power z, integral of fz is fz, integral of e to the power z is ez, plus in place of this I am going to put it another complex constant d, plus d, where d is my c by 1 plus. Okay, this is the analytic function in terms of z. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.